Hello everyone. Let's start with tutorial 2, higher order differential equations. The question says that we are supposed to solve the homogeneous linear differential equation with constant coefficient. It means that at the end of solution, we will be having some constant coefficients in the equation. Before we start, we'll try to understand the D operator, also known as the differential operator, given by d over dx. So this entire equation can be written as d square y by dx square minus 3 dy over dx plus 2y is equals to 0, which if I write down in terms of d, it will become d square minus 3d plus 2 of y equal to 0. Now from this, I can obtain the auxiliary equation in terms of the coefficient m, which is given as m square minus 3m plus 2 is equal to 0. So basically, in place of capital D, I have written m square minus 3m plus 2. Now over here, for this equation, I'll be splitting the middle term to find out the roots of this equation. To recite what are roots, roots are those values of m for which this entire equation will become 0. So I'll try to find out the roots of this equation. I can see the coefficient at the very first place, that is at m square, is 1, and over here it is 2. So the multiplication goes is 1 cross 2, which is equal to 2. So I have to split 2 into such a term that I get minus 3 as an answer. So the answer that I'll be getting will be equal to minus 2m minus m plus 2 equal to 0. Further, if I take the common things out of the two pair, the first two pair and the second two pair, I'll be getting in the first two pair, m is common, so I'll be getting m minus 2 inside. In the second pair, I'll take minus 1 common so that I get m. And since minus 1 is common, this sign will change, so I'll get minus 2 common again. So taking m minus 2 common out of it, I'll be left with m minus 1. So these are the roots of this equation. Now I will be using this thing to find out the solution. So from here, I can say for m equal to 1 and for m equal to 2, this entire auxiliary equation becomes 0. So the final answer for such a homogeneous linear differential equation is given as y of c is equals to c1 e raised to the power mx, or I can write down m1 over here, plus c2 e raised to the power m2 over x. Now, in this case, you can see that m1 and m2, they are not equal. So we have this kind of equation. And if I substitute the value over here, I'll get c1 e raised to the power 1x, that is x, plus c2 e raised to the power 2x, since the value of m2 is 2. So this is my answer. And as I told you, it will have some constant at the final equation. Let's try to see the next question over here. Now, in this case, I hope you remember the differential operator d square y by dx square. So this whole equation can be written in the form of d square plus 6d plus 9 of y equal to 0. So from here, if I want to find out auxiliary equation, it will be equal to m square plus 6m plus 9 equal to 0. Again, since I need to find out the roots of this equation, I'll be splitting the midterm, which will give me m square plus 3m plus 3m plus 9. So here you can see that 3 plus 3 becomes 6, and this 3 into 3 becomes 9. So from the first two terms, I'll be taking m common so that I'll be left with m plus 3. And from the second two terms, I'll be taking plus 3 common so that I'll be left with m plus 3. So from these two equations, I can take m plus 3 common and I'll be left with m plus 3. Now this is a special case where the value of my m1 is equals to the value of m2, that is minus 3. So for such an equation, the final solution of this homogeneous linear differential equation is given as y of c is equals to c1 plus c2 times x e raised to the power mx. Since the value of m1 and m2 is equal, I'm going to write it equal to m. So substituting the values over here, I'll get c1 plus c2 times x multiplied by e raised to the power minus 3x. This is going to be my final answer. Now let's try to see another question. Now this is an interesting question because there is some extra thing given over here which says that y of 0 is 0 and y dash of 0 is 1. Sorry, y of 0 and y dash of 0, both of them are equal to 1. These are known as initial conditions. These are known as initial conditions. So in this question, initial conditions are given to us and we'll be using to find out the value of the constant C1 and C2. So this entire equation, if I directly convert it into auxiliary equation, so auxiliary equation can be obtained as simply you can write down this d square over dx square as m. So you will left with m square plus 4m plus 4 equal to 0. Now, if you remember the formula of a plus b whole square, this it is applicable over here, and you can simply find out that this is equal to m plus 2 whole square. So here also the root m1 and m2, both of them, they are equal to minus 2. So as I told you, the solution of this equation, this homogeneous linear differential equation, will be equal to c1 plus c2 times x e raised to the power mx, which in this case will become c1 plus c2 x e raised to the power minus 2x. Now I'll be using the initial conditions. So for this initial conditions, I already have the value of y. I need to find out the value of y dash. Y dash is basically the first differential of this equation. Now to find out the first differential of this equation, uh, let's use the chain rule. So first of all, I'll be keeping this whole part constant. So I'll get c1 plus c2x multiplied by the exponential function. The differential of exponential function is the function itself, but I'll be using minus 2 extra over here. So I'll get minus 2 plus, now in the second part, I'll be keeping this e raised to the power minus 2x common. So this will be, constant. So this will be constant, and differentiating this entire term, I'll be left with c2 only. So y dash will be equal to e raised to the power minus 2x. This I can take common because it is there in both the terms. And it will become c1 plus, minus 2 c1 minus 2 c2x plus c2. Now I have two equations. I have two initial conditions. I'll be using them one by one. The first initial condition says that y of 0 is 1. So this is the equation of y. I'll be substituting the value of x equals to 0 over here. So I'll be getting c1 plus c2 multiplied by 0 whole raised to the power multiplied by e raised to the power 2 into 0 is equals to 1. Now over here, you might remember that anything raised to power 0 is 0. So this will, anything raised to power 0 is 1. So this entire expression will become 1, and I'll be left with c1 plus 0 into 1, which will actually become c1. So the value of c1 will be equal to 1. Now if I calculate the value of c2, I'll be using this second equation, the equation of y dash. We know that the y dash of 0 is equals to 1. So if I substitute the value over here, I'll get e raised to the power minus 2 into 0 minus 2. We already know the value of c1, so we can substitute it over here. The value of c2 into 0 plus c2, this is going to be equal to 1. So from here, this thing will become 0. This thing will become 1. This thing will become minus 2. So let's solve it up. 1 into minus 2 minus 2 C2. Okay, this whole thing will become 0. So there is no need to write down the middle term. Plus C2 is equals to 1. So if you solve this up, you'll get the value of C2 to be 3. So I got the value of two constants C1 and C2. I need to substitute it over here in this equation to get the final solution. So if I substitute the value, I'll get the final solution to be equal to C1, that is 1, plus C2, that is 3. So 1 plus 3x e raised to the power minus 2x. This is going to be my final answer. Let's move on to the next question. Now in this question, the auxiliary equation becomes m square plus 9 equals to 0. From here, I can write down that m square is equals to minus 9, or m is equals to under root of minus 9, which becomes 3 plus or minus 3 under root of minus 1. So if you guys remember it from your school, the under root of minus 1 is an imaginary number I. So the value of m will be 3i. Now for any of the imaginary number that we get in the auxiliary equation, the answer or the solution is given in terms of cos and sine functions. So this is given as e raised to the power alpha x multiplied by c1 cos beta x plus c2 sine beta x. Now in this case, if you see, alpha and beta, they are just the component of this imaginary number. So it is written as a plus ib, a plus or minus ib, right? So or alpha plus or minus I times beta. So if I substitute the value over here, the value of alpha, since there is no real number, it will become 0, and the value of beta, it becomes 3. So let's substitute this value to find out the final answer. So you'll get e raised to the power 0 into x c1 cos of 3x plus c2 sine of 3x. Now, since you know that anything raised to power 0 is equal to 1, so this entire equation will sum up like c1 cos of 3x plus c2 sine of 3x. This will be your final answer. Let's solve the next question. Now over here, the auxiliary equation will be given as m square minus 2m plus 5 is equal to 0. Now, as you can see, it is too difficult to split the middle term over here, since I'll get 5 only, and dividing the 5 to get 2, it is not possible. So I'll be using the solution of quadratic equation, which is given as minus b plus or minus under root of b square minus 4ac over 2a. Now, in my case, the value of b will be equal to minus 2. So minus of minus 2 plus or minus 2 square minus 4. Since there is nothing over here, I'll write it down as 1. The value of a will become 1 and that of c will become 5 over 2 times 1. So I'll get 2 plus or minus 4 plus 5 into 4, 20. Sorry, minus over 2. So this will become 2 plus or minus under root of minus 16 over 2, which becomes 1 plus or minus 2i. This minus 1 I'll take as imaginary number iota. Now over here I have the format of alpha plus beta I. So as discussed in the previous question, let's try to find out the solution in form of e alpha x c1 cos beta x plus c2 sin beta x. So this will give you e raised to the power x c1 cos 2x plus c2 sin 2x. This will be your final answer. Let's look into the answer of next question. Okay, now this is an interesting question where we have the cube of y. So the auxiliary equation will actually have three roots. So this will be given as m cube minus 2m square minus m plus 2 is equals to 0. So how you are going to approach this question? The first root can be obtained from trial and error method. Now if I substitute the value of m equal to 1, this will become 1 cube minus 2 1 square minus 1 plus 2, which is equal to 1 minus 2 minus 1 plus 2 is equals to 0. So m equal to 1 is one of the root of this equation, or basically I'll say that m minus 1 is one of the root of this entire equation. So I'll divide this m minus 1 from this equation to find out the rest of the part, which will be equal to m square. So I'll get m cube minus m square. Changing the signs, I'll get minus m square minus m plus 2. Let's multiply it by minus m to get minus m square plus m. Changing the sign again, I'll be left with minus 2m plus 2, or if I multiply it by minus 2, I can cancel them off. So simply I can write it like this, that m cube minus 2m square minus m plus 2, which was my auxiliary equation, it is the product of m minus 1 and m square minus m minus 2. Now for my convenience, further I will be dividing this equation by splitting the middle term. So I'll get minus 1 m square minus 2m plus m minus 2. Or if I take m common out of the first two terms, I'll be left with m minus 2, and plus 1 common from the second two terms, I left with m minus 2. So from here I can find out the roots, which are m minus 1, m plus 1 and m minus 2. So the value of m that I'll be getting is m1 equal to 1, m2 equal to minus 1 and m3 equal to 2. Now for this equation, I have three coefficients. So the solution will go like e raised to the power mx, m1x plus e raised to the power c2 times e raised to the power m2x plus c3 times e raised to the power m3x. Or if I substitute the value of m1, m2 and m3, I'll get c1 e raised to the power x plus c2 e raised to the power minus x plus c3 e raised to the power 2x. So this will be my final answer for this differential equation. Now let's try to solve the next question. Now over here you can see the equation consists of three roots, as well as these initial conditions are given to me over here. So I'll be using both of them. Let's find out the auxiliary equation first, which becomes m cube minus m square plus 100m minus 100 equal to 0. Now it's quite visible over here that if you substitute the value of m equal to 1, this entire equation will become 0. So simply I can write down that m cube minus m square plus 100m minus 100, it is divisible by a number m minus 1. Right. Now if I divide it, I'll get the answer m square this will cancel plus 100. So you can divide it using the method discussed in the previous question, and this is the answer you are going to get. So simply I can write down this auxiliary equation m cube minus m square plus 100m minus 100 is equal to the product of m minus 1 m square plus 100. Now again I need to split this term, or simply I can find out, I can write down that m1 equals to 1, m2 and m3, it is equal to plus or minus under root of 100, or sorry, minus 100, which is equals to plus or minus 10i. Now since this is a combination of two types of root, one being the real number, the second being the imaginary number, the final answer over here will consist of c1 e raised to the power m1x plus e raised to the power alpha c2 cos beta x plus c3 sin beta x. Now, interestingly, the value of alpha over here is 0 and beta is equals to 10. So I'll substitute the value over here to get the final answer, which will be c1 e raised to the power x, since m1 is equals to 1, e raised to alpha x is there. Alpha is 0, so it will become 1. I'll get c2 cos, the value of beta is 10, so cos 10x plus c3 sin 10x. This will be my final answer. Now, in this equation, I had to use the initial conditions to find out the value of C1, C2, and C3. Okay, so I'll take this equation into the next slide to find out the answer over here. So the equation that I got at the end as an answer was y is equals to C1 e raised to the power x plus C2 cos 10x plus C3 sin 10x. Similarly, I can find out the first derivative of this equation, which will become C1 e raised to the power x, because the derivative of e raised to the power x is e raised to the power x. The derivative of cos is minus sine, so I'll get minus 10 C2 sine of 10x. Similarly, the derivative of sine is plus cos, so I'll get 10 C3 cos of 10x. I can also calculate the second derivative over here, which will become C1 e raised to the power x minus the derivative of sine will be cos, so I'll get 100 over here, 100 C2 cos 10x minus 100 C3 sine 10x. Now let's try to substitute these values one by one. So the first equation I'll be solving over here, the y of 0 is equal to 4. So let's substitute the value of x equals to 0 over here. So I'll get C1 plus C2 cos 0 plus C3 sin 0 is equals to 4. Now we know that sin 0 is 0. So I'll be left with C1 plus C2 being equal to 4. The second equation, y dash of 0 is 11. So again, I'll be substituting the values over here. So I'll get C1 plus, so this is my first equation. This will become C1 minus, now this entire term, while substituting x equals to 0, will become 0. So there's no need to write this one. So I'll be left with only 10C3 is equals to 11. That is my second equation. And the third equation, I'll be using y, second derivative of y of 0 is minus 299. So if I substitute the values of x equals to 0 over here, this will become 0. So I'll be left with C1 minus 100 C2 is equals to minus 299. This is my third equation. So solving 1 and 2 first, or let's say I'll take the value of C1 from equation 1. So let me solve it over here. So first of all, equation 1, I'll take the value of C1, which is equals to 4 minus C2. So now I'll modify equation 2, which will become 4 minus C2 plus 10C3 is equals to 11, or minus C2 plus 10C3 is equals to 11 minus 4, that is 7. Let's assume it to be 4. Similarly, equation 3, I'll substitute the same thing. So I'll get 4 minus C2 minus 100 C2 is equals to minus 299, or minus C2 minus 100 C2 is equals to minus 303. Or from here, I can find out the value of C2 simply to be minus 303 over minus 101, which is equal to 3. So if I take the values over here, so I got the value of C2 to be equal to 3. From here, I can calculate C1, which will become 4 minus C2, that is 1. And I can also find out the value of C3, which will be equal to 11 minus C1 by 10. That is, sorry, yes, 11 minus C1 by 10. That will be 10 by 10 or 1. So I have obtained all the values over here, and my final equation will look something like, pardon me for the space, it will become e raised to the power x plus 3 times cos 10x plus sine of 10x. This will be my final answer for this question. Now let's try to solve the next question. Okay, this is also a question with 3 roots. So the auxiliary equation over here will be equal to m cubed plus 1 is equal to 0. Or if I take m equals to minus 1, obviously I'm going to get this equal to 0. So I can say that m cubed plus 0m square plus 0m plus 1. See, this, since I don't have the coefficients of m square and m, I have written 0. It is divisible by m plus 1. And when I divide it, I'll get m square minus m plus 1. You guys can divide it as the method discussed earlier, and you'll find out this answer. So I can write down this auxiliary equation to be equal to m plus 1 multiplied by m square minus m plus 1. Now, since it is quite impossible to find out the middle term of this equation, I'll be using the solution of quadratic equation given by minus b plus or minus under root b square minus 4ac over 2a. Let's substitute the values over here. So minus of minus 1 plus or minus under root of minus 1 square minus 4 1 1 divided by 2 times a. The a is 1. If we solve this equation, let's solve this up. So we'll get 1 plus or minus under root of, it will become 1 minus 4, that is minus 3 over 2. Or in simple terms, I can write down as 1 plus or minus root 3 I by 2. So I got 3 values of m. m1 will be equal to minus 1, m2 and m3. They can be given as 1 plus or minus root 1 by 2 plus or minus root 3 by 2 I. Again, this will be a combination of real numbers and imaginary numbers, and the solution can be given as y is equals to c1 times e raised to the power mx. The value of m1 is 1, minus 1. So I'll take minus 1 plus half c2 cos root 3 by 2 x oops, it should be equal to e raised to the power half of x plus e raised to the power half of x sine root 3 by 2 x. So this is going to be my final answer after substituting the values of m. Let's solve the next question. Okay, so over here we have four roots. So the auxiliary equation, it will be given as m raised to 4 plus 8m square plus 16 is equals to 0. Now over here, this equation in simple terms can be written as m square plus 4 whole square equals to 0. So I can write down that m square, the value of m square is minus 4 and minus 4. Since this is square, it will be repeating two times. And the value of m, it will be under root of minus 4, which will be equal to, actually this should be written two times. So I'll be having plus or minus 2i and plus or minus 2i. Now this thing is being repeated two times. So the equation, it will be written accordingly. You might remember it from the last question that if the number is repeating itself, we write down c1 plus c2 times x e to the power mx. Now over here, this thing will be repeated twice because we have m1 as well as m2. So, and that to an imaginary number. So this will be cos as well as sine. So I'll be having c1 plus c2 times cos c1 c2x cos 2x, since the value of m is 2, plus c1 plus c2 x sine 2x. This will be cos 2x plus c1 plus c2x sine 2x. So this is the final answer I'll be getting after solving this question. Well, that's it for this video. Thank you so much for watching. Stay tuned.